So I'm Joe Schneider from Bunchball. And first off, because they pay me to come here, I figured I'd do a little shout out. So Bunchball is gamification as a service, software as a service type thing. And basically what happens is we use the data that you're already collecting about all your customers, employees, and stuff like that. And we allow you to sort of kickstart motivation, kickstart employee motivation. If you want to talk about gamification in depth, then come talk to me after. This is not what I'm talking about now. I'm talking about Kubernetes, so the technical side. That's what you're really here for. So, but primarily from an engineering side, Bunchball is an API. Like that's what we do all day long. It's basically a Java app, very large one, monolith we're breaking down, with all sorts of dependencies on the back end. So before we were in physical data centers, and we used Puppet extensively, and we're trying to like manage everything. We have all sorts of customers all over the place trying to share data centers. So we moved to AWS like ages ago, and AWS plus Docker is super huge because then we can basically don't have to install all sorts of shit with Puppet on the host. We can just say, hey, if it has Docker, then we can make sure it's running any app. It could be a database, it could be Node.js, doesn't matter. So that's the easy part, right? The easy part is you get some sort of app on a server, and hermit apps is what I like to call them. So the things don't talk to anything else, they're relatively stateless. The hard part is linking these things together. So see all these sailboats? That's all these different islands talking to each other, and that shit is hard. So that's where Kubernetes comes in. Like, I just got to say. Also, this audience is way too polite. So if you have a question, just like shout it out, okay? So here's where Kubernetes comes in, is namespaces. Because like you saw a little brief thing, like you were saying like, oh, I'm doing all this work in this namespace. Well, what we're doing is we have ephemeral namespaces such that we have a namespace that only lives for exactly as long as we want it to be. So it could be a single customer is in a namespace and we can limit resources there, or we could have a namespace just for testing, and you're going to see that in a bit. So the thing that allows us to do is like literally hard code. I want to talk to MySQL. It's a DNS entry in MySQL, and you know that it's going to go talk to the right one. You don't have to say like, you don't have to do some sort of lookup of, hey, I want to go like MySQL 17. No, because the server you're trying to talk to is the only one in your namespace, so it's the only one that's there. So it's pretty sweet, and we can go into that. The catch is with all this is that you can't quite 100% do that because not every namespace is exactly the same. Some customers are larger than others, and usually they pay us more, so we give them more resources. Some are like the little guys, and we do appreciate them too, but we're not going to go kick up an entire data center just for like, $200. So that's where ERBs come in, and I'll show you that in a second. So here's the moment of truth. Hopefully the demo gods will smile upon me. If I can get out of this presentation. All right. So you guys want to see a real production stack and not a toy problem in Kubernetes? Here we go. So here is our entire production stack running right now. As you can see, zoom in. All right, that's going to be tricky without my mouse. Can you give me my bag real quick? That's going to be, I appreciate that that's really small print. I have good eyes, but maybe no one else does not. Okay. Set up. All right. There's a mouse in here somewhere. Maybe? Yes. All right. I just needed the scroll bar. Sweet. So, is that big enough? Maybe a little bigger? Make it bigger. All right. Yes, yes. There we go. You got it. Okay. No. All right. So here's our pod. So as you can see some Redis in here, a little RabbitMQ. The things that look a little wonky, these are actually MySQL databases. And for this demonstration, we don't use the persistent storage because this is where we're testing stuff. So let me do a little magic here. I'm going to go to my little repo. This is a metadata repo that we have to manage Kubernetes. So let's do Nitro. Nitro is the name of our product. We're basically a one-product company. So let's do deploy. You probably can't see it with the hide thing here, but deploy. And let's do integration test. So this is going to you're going to see things going across the screen. So it actually deletes the namespace that I have up already, and it's going to recreate all the stuff. Now, it takes a couple minutes, so I'm doing this now. It's jumping a little bit ahead. You remember that book in English class where like it started you in the middle? That's what we're doing right now. So just hold on a minute. You'll see some stuff go by the screen. Try to memorize every single character, and then you can go from there, and I can talk about it. So it's creating some services, stuff like here, you see that. So there's an Nginx service, RabbitMQ, Redis, stuff like that. There's some warnings coming up in here. I'll tell you what those are later. Don't need to worry about that. It's creating the databases and replication controllers, like you said. So yeah, hopefully this will be done soon. We have a mid-tier thing in here, which is a custom app that we have that like hooks things together. All right, so you also see here this config use context to talk to integration tests. So let's start with this. Oopsctl get, oops. So you see I have a couple namespaces in here. We're talking the integration test one. So kubectl, let me show you a little bit simpler one than the one he had that wasn't mine's not auto-generated. Oops, config. Absolutely. I'm nefarious that way. So here's mine's a little bit simpler, right? Like I basically just have like, here's my APIs, my cluster, dev kube API. This is our dev cluster. All right, kubectl get pods again. So you see things are starting up, right? It takes a couple minutes, but you know, that'll keep doing that. So while I'm going that, let me make sure on my slides that I'm not forgetting something interesting. Nope. All right. So how did I do all that, right? So you saw the config in there, and let's just go into it. So let's go to one of our database ones. Let's go, I don't know, site comment. That seems interesting. Oops. Them. I love you, but I hate you. So it's just an ERB, right? So we have, you know, probably not the most complicated thing, but certainly not like a toy problem. And all you do, if you're familiar with ERBs, this is just basically calling out a variable. And that means so that every single one of these config files that I have to specify the namespace, so I can actually create this without being in any particular namespace, and Kubernetes will just put it in the right one. I have a version here, stuff like that. So let's go look at where this is generated. So I'm going to go up here. And if I'm going too fast, just like tell me to slow down a little bit. When I put in this like special magic YAML here, this is what this is. This is basically populating all of the different things. So like, let's say my app has a certain version on it. This specifies the Docker image version, stuff like that. Some of these are more static, the integration test one, stuff like that. And I specify some ports. That's because we're not using the Kubernetes ELB integration, so we don't have Kubernetes create an ELB for us. We have one that's sort of static, so we have to figure out, map to a specific port. And you can also see my shenanigans here earlier today when I had problems with ELBs, so I just sort of like did this little hack. So what this does is basically goes to one of my nodes and has this port open on there. So I only have 20 minutes, so I don't have that much time to go through it. But all right, let's do this kubectl get pods. All right, looks like everything came up and running. Yes. Let's see if it actually works. So I'm going to go to here. Let's go to login. So this is actually a stale page, but maybe I can log in. Yes, please. Ooh, that's good so far. And not quite perfect, and you'll see why, but the challenge is in here and stuff like that. So as you can see, it's not quite 100% working in there, and I'll tell you why that's important. So Bunchball's been around for a little bit, and we're not exactly greenfielding this whole thing. Like, we have a whole system, it's working. We've been, people have been paying monies for years, which as a startup, I'm sure you appreciate. And we can't just like totally rip everything out, put in some new fancy little system, and then call it a day, and like our customers are going to be super happy with us because we have the latest shiny toys. They don't care about shiny toys. They care about their shit working. So we have to make sure that it works, right? So for us, what we are doing is I can run test against, this is the same test suite. I'm going to go into config here. No, rebuild last. There we go. And I'm running the test suite against the new Kubernetes system, and this is the same exact test suite that runs against our existing code base. So I can go in and say every time a new change is made to, and you'll see there's a sleep in here because I have this auto building and sometimes it takes a couple minutes for this thing running, but anytime a change is made to our app, then a Kubernetes namespace is made automatically on demand, and we do the full test suite against it. And if we let this run for a little bit, you'll notice that a lot of them are still failing, which is an important thing. It's not just going to work. You can't just like take your existing thing, slap it into Kubernetes, and expect it to work. You actually have to re-architect your stuff a little bit. So that's what we're in the middle of doing now, and we're almost there. I think we have like 90% test suite completion. Let me go back to this. So as you can see in here, this is my namespace in terms of things being available. Now, because we delete them and recreate them like very frequently, these monitoring things are a little wonky, but you do have access to see what's in here. Like these are, when I did kubectl get pods, that's this stuff, right? And I can go in here and see what it's doing, and this is the special monitoring that. I can look at all my nodes, and here's all the nodes in my cluster. It's a relatively small cluster, but it's just for devs. So, and I can see sort of what it's doing, all the different pods that are on it. But I can do all this through the command line too. So kubectl get services, stuff like that, which, whoa, that is not at all helpful because that, yeah, too much stuff on the screen. All right, anyway, but let's go ahead and run this through Jenkins. So let's pretend we're going to make a change, and let's do our Nitro build, which is just going to like run of our apps, build now. This is going to take a couple minutes, but you'll notice that this downstream product is kube deploy Nitro, and that's all it's doing. So if I go in here, this is going to run, but let's go check it out a little bit. Let's go see what it's doing. And all that it's doing is basically this one line. I have a Docker container that contains the little Ruby script that I made that all it does is take an ERB variables format, variables YAML, like I showed you before, populate all the stuff in ERBs, and go from there. And that's all it does. It's relatively simple. So that is running this stuff. So that is the magic. That's super high level. I sort of wanted to leave some time for questions, which hopefully I can do Kubernetes tricks, maybe some juggling. I don't know if people are into that. So this solved the problem that we had. So if I go into Nitro 1 as a different namespace, you can see that it's completely different values. So this is value. And we can just create them on demand. If I want to make a new one, then CP integration test to, I don't know, what do you want to call it, bananas? I don't think I'm spelling bananas correctly. B-A-N-A-N-A-S? Okay. Let's go with bananas. And I can change the namespace to bananas. Bam. And I do a deploy, which we can look at in a second, bananas. And it's doing the same thing. It's creating a bananas namespace with all this different things. Now, this is going to fail because I have statically defined ports, which we're going to see in a second. But my Ruby script checks that. Hopefully, maybe it will fail. Maybe it won't fail. Interesting. I was expecting it to fail. Let's just let that finish. The unexpected successes. Oh, this thing right here? Luckily, there isn't a production space yet, but hopefully by the end of December, we'll be running this in prod. That's my hope. So yeah, kubectl get namespaces. Oops. And here we are. Here's our bananas. It's right here. So kubectl config. Actually, I'm going to go do this. There is a way in the kubectl command thing to actually configure it on the fly, but I find it really hacky. So I'm going to go in here and just hack this thing together because let's put bananas in here. And let's call this bananas. Why did I pick bananas? I should have picked something shorter. Oops, that's not correct. All right, so kubectl config set context, which is like obvious, totally obvious, right? Everyone knows exactly what's going on, right? And bananas. So kubectl get pods. So here's my shit, and I'm in the under namespace, and things are still starting up. I'm actually surprised some of this might be working, but I'm probably running into resource limitations because I have a small server. So you asked before about the persistent data. So let's go into here and how I would do this. And I'm going to go to kube content, Nitro, databases, Vim, global comment. Oops, that's... RC. All right, so if I go down here, where that is done is volume. Maybe I didn't do a volume. Well, you would put it in here, basically. You just have like a thing in here. I can do volume, blah, 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 and type. I think this I'm not actually going to save this because it's type like empty, stuff like that. But basically, it's just like a couple more lines in here, and you're done. And you can have stuff where Kubernetes will automatically create an EBS for you. That's not what we're going to be doing, but you can do stuff like that if you want to get started. And it makes it super easy to just make things linked together. So I have all sorts of things I can show you. Let's just do that. So, oh, there's a question? Heard a question? No? So let's change context. So config, use context. We're going to be using RDS. So the intention is for a temporary type thing. I'm not going to be running these databases here because Amazon is super sweet and it just has these things managed for us. Because anything that I can pay for and I don't have to do myself, I'm totally for. Because maybe I'm just lazy. I don't know. So yeah, we don't have like all the time in the world to set everything up ourselves. So that's what we're going to be doing. And yeah, and we'll just have service set up for it. You can have services such that you can point to things outside of Kubernetes. You can have an external database that point out there, which we'll be doing as part of our transition. Which is another important point, is that you can have part of your infrastructure in Kubernetes and all your old shit outside of Kubernetes, and it will still work. And it's really not that much extra work. So because of the way services are so sweet, which I can wax eternal on those. But for RabbitMQ, we're not using it as persistent. Basically, if that dies, then we're like, oh, okay, fine. For Kafka, which is one we're doing later, we're probably going to be using Kinesis. Just another example of like, if it has to be persistent, then you can do it. Now, Elasticsearch is another thing that we're not going to be using Amazon for, even though they do offer a service. And for that, we have a mounted volume. And how we're doing that is basically, we will mount it to the host, but really the host, the host is going to be something like this, like opt Docker, and it's just going to be in a particular location on the host that we know is there. And the reason we do that is because we don't want contention in terms of one Elasticsearch cluster is going to have this thing, and it's going to only talk to that particular one and other things like that. So that is our plan for that. We may eventually have Amazon host our Elasticsearch cluster, but that makes us a little nervous because we really like the way we have it set up right now. So. Cool. So yeah, so this is the real world, right? This is not, Google's little lab where they come up with all these fancy new ideas, right? Like we have shit to do and we want stuff that works. So we have our old castle and it's really solid, it's really stable, and we really want to move into space, right? Because space stations are cool and really flexible and they go really fast, right? But there's a lot of things that happen between point A and point B that you need to be able to do, and you need to do it right? So that's how we are. We're hiring, obviously, just like everyone else. And if you think that the stuff we're doing is pretty cool, then come check us out. And also, any questions? Crickets.
Well, on the you're running Jenkins there.
Yeah.
Are you running it inside the cluster, or is that a separate service with view of the Kubernetes?
So we already had a Jenkins cluster or Jenkins system set up. I set it up months and months ago. So it's not currently running in Kubernetes, but the way you can run it in Kubernetes, and the way you would do that is not in privileged mode, and there's all sorts of various things with that, which I could talk in depth or I can talk right now. But yeah, you basically have ephemeral nodes. Like what we have is like 3 static nodes, which are 3 hosts, which are doing basically jack shit all day long, except for like the one time that developer needs something, or when we do our entire rebuilds on Monday, which is really wasteful, right? Like these have to be somewhat beefy machines in order to like do things quickly and get turnaround for the devs quickly. So we'd really like to put that in Kubernetes so that we don't have to do that.
So it seems to me that you are passing in queue control as part of shell within the Jenkins job.
We run a Docker image that I specially crafted that does that, and I can actually show you the script for it because all it's doing is running a Ruby script. Mundus. So it's this little mundus.rb thing that I got here. Now, there's some caveats here, right? So if you're creating all your stuff all at once, you have to do namespaces first. So I have to do all this extra handling because if you try to create resources in a namespace that doesn't exist, Kubernetes is like, nope. So that's what we have to do. So I have to do like 3 different things. And the other thing is because we're using static ports, or I actually put comments in my code. Isn't that great? Everybody clap for comments in code, right? So you have to do services as well. If you do static services like we do, because we're not using Kubernetes to create the ELBs for us, so that has to be handled with a looping. So it takes a while. I don't know, at least almost a minute or possibly sometimes more for Kubernetes, or not. It may not be Kubernetes. Somewhere in the system is not releasing the port quickly enough, and so we have to be like try a couple times until it does it. So I have a for loop in there that does that. I'm a fan of Ruby for scripts just because it just makes things easy, but you can write it in whatever the hell you want. You could do this in Bash if you wanted, although please don't. So.
Okay. I think we've run out of time now.
We're out of time. All right, well, I'll be around after, so you can come parade me with questions. All right, who's next?
Thanks. Okay.